So now we're in lesson 2, and this is going to be right triangle trig, formulas, and properties. You'll use trigonometry to calculate the length of sides or measures of angles of right triangles. You can calculate the value of all 6 trig functions, and you can use the law of sines and cosines to find the measure of angles, sides, and right triangles. First off, if you're in class, you're going to watch a cute little video called Get Triggy With It. It's kind of corny, but hey, it's an intro. We're going to skip that here and go right into your review from pre-AP geometry. In pre-AP geometry, you learned about the Pythagorean Theorem. A squared, or in actually pre-AP Algebra 1, you should have learned about the Pythagorean Theorem. A squared plus B squared is equal to C squared, where A and B, we call those the legs, and C is the hypotenuse. Yay! Now the converse over here, we're not going to spend a lot of time on. You learned that in pre-AP geometry. We're not going to use it so much here in this trig unit. But the Pythagorean Theorem, golden. This is so important. Gotta know it. Gotta love it. Moving on, we learned about Pythagorean triples. A Pythagorean triple is a set of 3 whole numbers that solve the Pythagorean theorem. They're common ones, like 3, 4, 5. That's the most common. There are some other ones that you start seeing a lot when you work with right triangles. Now, within right triangles, you also learned about certain ratio of sides. If you know you've got a 45, 45, 90, because that's a special right, then whatever the length of this leg, then you know the length of this leg. If the angles are equal, then the length of the legs are equal. And then you learned that the hypotenuse is just the length of the leg times square root of 2. Now, are you just taking that on faith? No, we got to prove it. So, remember that if we've got the Pythagorean theorem, we know that n squared plus n squared will be equal to our c squared. This little guy over here is c. So now you have 2n squared is equal to c squared. Taking the square root of 2n squared is equal to c. But remember, we have to simplify radicals. So you have n square root of 2 is equal to c. That's how this value is obtained up here. Now, we only have to worry about the positive root, not the negative root, because we're looking at the length of the hypotenuse of a triangle. And that length can't be negative. Okay? So now we've proven the 45, 45, 90. The 30, 60, 90 was a little trickier when you did this in geometry. Essentially, you're going to start with an equilateral triangle, where this side is 2n, this side is 2n, this side is 2n. But when you drop an altitude in your equilateral triangle, making a right triangle, you split this 60-degree angle up here into a 30 and a 30. You also split the length of the sides down here into n and n. So now you have a 30, 60, 90 triangle. You also have shown, doing this, that you have 2n and n. But now we need our long leg. So we have the hypotenuse. That's our 4n squared. And that's going to be equal to this side, which is n squared, plus b squared. That's this side right here. We don't know what that is yet. So now, if 4n squared is equal to n squared plus b squared, I subtract n squared from both sides. 3n squared is equal to b squared. I take the square root of both sides. Square root of 3n squared is equal to b. Again, simplify the radical, and you have n square root of 3 is equal to b. And you've shown how to get all 3 sides of the triangle. Okay? So 45, 45, 90, and 30, 60, 90 have patterns. Those patterns are so important. So important as we move forward. Now, in trigonometry, when you were in pre-AP geometry, you learned that the sine is the opposite over the hypotenuse. This is that whole SOHCAHTOA. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. You have so, ca, toa. Now, if we label a right triangle, then I can look at sine of A. This angle is the opposite over the adjacent. If I'm looking at B, if I'm talking about angle B, then the opposite is AC over AB. Likewise for cosine and tangent. Okay? Now the things that you need to write down are the items that are underlined in blue. You will have a graphic organizer given to you. You will need the things underlined in blue. Right. Now we have law of sines. Remember the law of sines? This is when we have oblique. I can't write vertical, but these are oblique or not right angles. Okay, so I'm actually going to move this guy down. Oops. I'm going to do this. I'm going to do a select all. I'm going to move them all down. And up here, these are oblique, if I can spell, triangles. And this means not right. These are not right triangles. Okay? So this is just a quick peek at this. We're going to get into this a little bit more later. But this is still trigonometry that you learned in geometry. So I wanted to just do a review. This is the review of all your geometry. So law of sines and law of cosines, we're going to look at this a little bit here. We're going to look at it a little bit more later. You learned that when you have an oblique triangle, means it's not a right triangle, that you can use the law of sines and the law of cosines to find the length of different sides. This will be a lesson that we will do on another day, but it goes well here because it's part of what you've already learned. It's your base knowledge. Now, when you did law of sines and cosines, and you did not even law of sines and cosines, but just right triangle trig, you learned about angles of elevation and angles of depression. You can't forget those. You don't have anything to write about this. This is a story to help you remember elevation and depression. So, this is a story about Clarissa and Giorgio. Giorgio, he is a Roman soldier, and he is going off to fight the good fight and bring honor and glory to Rome. So, as you can see, he's very happy. He's going to go off and do his job, and that's what he's trained for. Clarissa, on the other hand, who's sitting up here, ready to say goodbye, well, she's looking kind of sad, a little depressed, because she's in love with Giorgio. And while there's a part of her that's happy he can go and do what he needs to do, what he's been training to do, she's sad because, well, she's left at home to do the cooking and the cleaning and the taking care of things, and she's just going to miss him terribly. So, and she also knows that when he goes away to fight the good fight, he could die. So she's sad. Giorgio, however, is with all of his friends, and he's all happy and ready to go. So he's happy. Clarissa comes to the edge of the cliff to wave goodbye to Giorgio as he leaves. She is looking down at him at an angle of depression. Her line of sight, going straight out, she has to go down or depress to get to Giorgio. Giorgio, on the other hand, is standing there ready to go with his buddies. His line of sight straight across, horizontal, and then he looks up or elevates to see Clarissa. Angle of elevation, line of sight up. Angle of depression, line of sight down. Let this short story of Giorgio and Clarissa help you remember which one is which and how to draw an angle of elevation and an angle of depression. And again, you should have learned that in geometry. I'm just reviewing. Now, did you know that you knew so much? Well, you do. So before we start introducing some new stuff with the trig, let's do a little bit of practice with this prior knowledge that we've reviewed. First, we have the Pythagorean Theorem. It's a squared plus b squared is equal to c squared. Pause the video and work out problems 1 and 2, solving for x. Don't be funny and just circle x and say, here it is. Find the length of the missing side using the Pythagorean Theorem. Pause the video. you're back. Check your answers. Did you get 4 root 5 for x? And did you get 2 root 23 for x over here? In number 1, you're solving for the hypotenuse. In number 2, you're solving for one of the legs. If you need more time, pause the video. Make sure you've got the right work. Okay, next up are our special right triangles. Remember that we said that the leg, and if you used n, because that was in our previous notes, fine, n works well too. So we have 45, 45, 90 is x root 2. For the 30, 60, 90, we have x root 3, and 2x. Short leg, long leg, and hypotenuse. Now, you've got 6 problems here. Find each missing side. Give your answer in simplest radical form. So remember, if you've got a 45, 45, and you know one of the sides, you should be able to figure out the other sides. Same thing with 30, 60, 90. So pause the video and try these. See how you do. You're back? Still quick? You're good. All right, 45, 45, 90. That means if this is 10, this must be 10. And then this must be 10 root 2. Pretty straightforward. For this guy, we have a 45, 45, 90. But this is a little harder because remember that the 16, that's equal to x root 2. So now you've got to do a little bit of calculating. Hopefully it's not too hard. And you get 16 over square root of 2 is equal to 16 root 2 over 2. How did I get this? Well, I'm going to work this one out. The others we're just going to look at. If we had that 16 was equal to x square root of 2, divide both sides by the square root of 2, and you have x. Remember from geometry, we can't leave a radical in the denominator. So we have to use the multiplicative identity and multiply by a form of 1. In this case, we're going to multiply by square root of 2 over square root of 2. This gives us 16 square root of 2 over 2. Square root of 2 times square root of 2 is 2. That's what is equal to x. Now 16 is divisible by 2, so we just have 8 root 2 is equal to x. Since it's an equilateral triangle, a 45, 45, 90, once I have x, I also have y. Okay, that's how you do it. So, taking a look at number 6. Did you get 14 and 14? It's nice when they've got the root 2 here. You just lop that puppy off. Number 7 gets into a 30, 60, 90. We have the hypotenuse. That's twice the short leg. Twice the short leg. So x should be easy. That's 4. Y is going to be the short leg times root 3. 4 root 3. Pretty quick and easy. Now here, you're given the long leg. And this again is where you're going to have to take and say 27 is equal to x square root of 3. 27 over the square root of 3 is equal to x. Then rationalize it, and you'll have what x is. Did you get 18 root 3 and 9 root 3? Hopefully you did. And finally, number 9, we have the short leg is 5 root 6. If we have the short leg, we know the hypotenuse, and 10 root 6, and we can figure out the long leg. Okay? It's the short leg times the square root of 3. And simplify the square root of 18. If you're not sure about that, I'll do that one right here. Square root of 18 is the same thing as square root of 9, square root of 2, square root of 9 is 3. And then we can take that 3 and multiply it by the 5, and that's how we got the 15. Okay. Hopefully this is coming back. You're getting a little more comfortable. Excellent job so far. Now we're going to add to our trig knowledge. Yes, we're going to add 3 new trig functions to the ones you already know. A trig function is a function whose rule is defined by a trigonometric ratio. A trigonometric ratio compares the lengths of two sides of the right triangle. Now, it's just a ratio. The Greek letter theta is used to represent the measure of an acute angle in a right triangle. We already know sine, cosine, and tangent. Opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. The reciprocal functions are the ones that we're going to learn. What is a reciprocal? You flip it upside down. Flip. So, if I flip opposite over hypotenuse, I get hypotenuse over opposite. We give this a special name, and it's cosecant. If I flip the cosine upside down, I get the hypotenuse over the adjacent, and we call this secant. And flipping the tangent upside down, I get adjacent over opposite, or cotangent. Notice that the cotangent is equal to 1 over tangent theta. Secant is equal to 1 over cosine theta. Cosecant is equal to 1 over sine theta. Now, I know tangent and cotangent make sense. Those are real easy. Everybody gets those fast. Sine and cosecant, cosine and secant, students hate. When they first learn them, everybody hates them. Why? Because they just don't make sense. Why isn't sine and cosine reciprocals and secant and cosecant reciprocals? I don't know. I did not name them. And I haven't really investigated the naming of trig functions. What I can tell you to help you remember this is that each pair has only one co. So you have sine and cosecant. Cosine goes with secant. Tangent goes with cotangent. Okay, so they're just each other flipped upside down. So taking a look at some of these, I need to find all 6 trig ratios for theta shown in the triangle below. So I've got 30 and I've got 16 as the legs of a right triangle. I can find the hypotenuse using the Pythagorean theorem, and I've done that here. Haven't asked you to do it, but I've got the work so that you could do it, because on a test, this is all you might get. Now, once you know that the hypotenuse is 34, the rest of these are easy. Sine, opposite, and here's your theta, so opposite over adjacent, or over a hypotenuse, sorry. 16 over 34, reduce it. Cosine is adjacent over hypotenuse. 30 over 34, reduced. Tangent is opposite over adjacent. 16 over 30, reduced. Now, once you have your 3 primary trig functions, finding the reciprocals are easy. You simply take all 3 of these and flip them upside down, rationalizing the denominator if necessary. In this case, we have no radicals, so it's simply flipping everybody upside down. Okay? And you could also do the 34 over 16. I personally, once I get the first 3, I just flip. Now, number 11, given the ratio for cosine theta, find the remaining ratios. Again, you're given cosine theta. Now, this does not mean that you know exactly how long the short leg and the long leg are. You know the ratio of the lengths, not the actual lengths. Very important differentiation here. We're going to learn how to figure out the actual lengths later. But when you're doing the ratios, cosine is opposite over hypotenuse. So this is 2, this is 3. You can think of it as putting a 2x there, okay? So this is 2, this is 3. Well, if this is 2 and this is 3, I can use the Pythagorean theorem to find out my multiplier so that I can keep this triangle in its same ratio. Any triangle with any different lengths of legs and hypotenuse would still be similar to this one. So once I have my adjacent, my opposite, and my hypotenuse, I can find my sine, opposite over hypotenuse. Come on, buddy. And, all right, hang on, I'm going to pause this so I can get this to move out of the way. I know it should. Okay, not certain what's going on, but at least I got these moved out of the way. So, they just don't want to disappear. I might have too many things opened up on my computer. root 5 over 3, opposite over hypotenuse. Tangent is opposite over adjacent. Now, notice when I flip root 5 over 2 upside down, I have to rationalize it. Same thing up here for the, we'll put this in here. Oh, okay. Cosecant. Now, you're going to use all of this information as you work on your practice work, okay? Trig ratios of special angles. I've got a 45, 45, 90, and a 30, 60, 90. When you've got something like this, write in what you know about those special rights. Write in the sides. Okay, I've got a 30, 60, and 45. These are frequently used angles in trig. You can use this knowledge of the side relationships to find the values of trig ratios. So, again, sine of 45, that's opposite over hypotenuse. That's just root 2 over 2. Notice that the x's cancel. What's the cosine of 45? Well, the cosine of 45 is the same thing as the sine because opposite and adjacent are equal. Now the tangent, opposite over adjacent, is just 1. Okay, looking at this, pause the video and see if you can do the 30 and the 60 degree angles for sine, cosine, and tangent. Back already? Good job. All right, let's check. Did you get all of these crazy answers? Yes. Now, this is not in the notes that you received, but if I know that the sine of 45 is root 2 over 2, oops, let's give myself a pen. What is the cosecant of 45 degrees? Well, the cosecant is just this guy upside down, or 2 over square root of 2. Can I leave it that way? No. But as soon as I rationalize the denominator, I'll get 2 square root of 2 over 2. Those cancel, and I'm left with square root of 2. Whoa! How about the cosecant of 30 degrees? Well, just turn 1/2 upside down and you have 2. So easy. What about the cosecant of 60 degrees? Well, that's going to be 2 over the square root of 3. I'm going to have to do 2 root 3 over 3. Got to rationalize it, right? And that one doesn't cancel anything, so I leave it there. Now notice that these two are the same. Notice that these two are the same. So now I can very easily do the cosecant here, or sorry, the secant here and the secant here. Tangent, well, those are easy to find the other ones. The cotangent of 45 degrees, oh, flipping one upside down is just 1. Over here, if I take this guy, the cotangent of 30 degrees becomes 3 over root 3. So I have 3 square root of 3 over 3, or just root 3. For this guy, remember he's over 1. So the cotangent of 60 degrees is equal to 1 over the square root of 3. Rationalizing it, you get the square root of 3 over 3. Notice you got a lot of numbers that are the same. Okay? All of this, it's going to start gelling, start making more sense. You should start feeling, even if you don't have a really 100% I feel good about this grasp, there should be this niggling feeling, this it's like just getting to you in your brain. You're seeing patterns, and maybe you can't quite put them all together, but you're starting to see that there's patterns here, and it's all going to get clearer as we move forward. Great job.